So yeah, please let me know what you're up to. If anything exciting has happened in the last couple of days, throw it up in the chat. It's been a good couple of days. I had a really great day yesterday. Just I watched the original episode of Star Wars. I forgot just how much fun those movies were. And it's really fun, like looking back after like several years, being like, oh yeah, that's what special effects look like in the 80s. So that was a lot of fun, and had a really nice potato nachos last night. Super delicious. Cousins in town, Luke. Oh, awesome. Haven't seen them in a couple of years. That's amazing. Hopefully you have a good visit with them. Good afternoon to you, Holly and Heather. Yeah, for just a couple of years ago, really. Lytton, BC. It's nice and sunny. That's awesome. That's great to hear. And Heather, you got your car back from the body shop after deer versus car. Oh no. I can't imagine that either the deer or the car won that battle. Those battles typically tend to be a little messy. But good to hear that you finally got the car back. Hopefully that was covered by your insurance. Oh, good. It was just a little mirror incident. Okay, that's good to hear. Yeah, I'm always sad. We actually had one here in Kelowna, like right close to downtown Kelowna. Deer was crossing Clement. We were outside just having wine on the patio, and just hear this like crazy crash. And we looked outside, and it was someone who hit a deer right on the highway out here. So yeah, they can be quite, I think, quite sad incidents for both for both the nature and human perspective. So. Got a couple more minutes here to let some people sneak in, trickle into class. I just remind everybody that test 2 is coming up next week. I will be available between 2 o'clock to 4 o'clock, so the full 2-hour class time. And I believe that 28th, yeah, is in 1 week. So it's next week on Thursday will be test number 2. So I have a couple of things up here for you. I have the practice test that the online test was modeled after, as well as the solution key. Please note there are a couple of errors in the solution key if you decide to work on the practice midterm, the hard copy version. So the errors are listed here for the questions that I've noticed have had a couple of errors on them. I've also posted up a practice quiz number 2. So this is based on some of the quizzes that I had in my online class last year. So again, just kind of getting you introduced to the style of questions, how to input things on Moodle, and the things that are typically asked for as a part of the test. I have increased the time limit for all portions of the test to 25 minutes from 20 minutes. So each portion of the test now gives you a little bit of extra time to get those final answers inputted into the test. And just like before, it's going to be available between 12 and 6 o'clock. And I will be available between 2 o'clock and 4 o'clock if you have pressing questions. The Dropbox will be open until 6:30. So once again, I highly recommend doing all of your work by hand. If it's if there's a couple parts or something like that, and you just want to kind of jot down some thoughts, upload all of that as a document to the Dropbox, and I can kind of follow along with your work and then award you partial marks like I did for test number 1. So that is upcoming. That is test number 2. So please do take some time to look at least the practice quiz. And if you have a bit more time, you got the practice test with the full solution key there for you as well. I have also uploaded assignment number 3 for you. And I've updated it as of yesterday. So assignment 3 is available, and by the end of class today, I do believe you should have all of the information that you do need to do assignment number 3. Assignment number 3 is not due until November 5th, so you technically don't have to start it until after the test. And we can talk a little bit more in depth about what's required after the test. We can talk about it in a couple Tuesdays from now. But it will be very similar to assignment number 1, where there's going to be a written portion and a video portion. And it's going to be a time diagram kind of question. So like all of the assignments, you'll go into the group choice section, tell me which question you'd like to do from assignment number 3, and there's a Dropbox for you to upload both your PDF and either video component or a link to a YouTube video or some other kind of video platform if that's what you choose. So that should be on your radar as well. Assignment 3 due November 5th. And as always, if you have any questions about those assessments, just let me know, and I'm happy to kind of answer those questions along the way today as well, or at the end of class. So what we need to do, what's on the docket for today is we would like to chat a little bit about the formulas for P, N, and I with regards to compound interest. So have you all had a chance to read the section of the textbook where they develop the formula for N and develop the formula for I? Okay, so I have a few of you saying yes. If you haven't had a chance to do that, I'm just going to assume that you know the formulas or have access to the formulas. And my goal today is to really try to go over as many questions as we can in the next 50 minutes or so, so you feel a bit more comfortable with how to set up these problems and how to execute them on your calculator. So we will need some kind of calculator today. I'll be showing you how to use the business calculator to do inputs. Let's get started with our first example here. So what we have in our first example is an investment that grows from $300 to $560.15. And let's assume that this happens over the course of 3 years. Okay, we know that interest is compounded in a bi-weekly way. So we're going to earn interest on our investment every other week. That's what bi-weekly means. We would like to determine the nominal rate. So in other words, we'd like to figure out, what is the rate of interest that the bank is actually going to advertise? It's going to be blank percent compounded bi-weekly. That's what we call the nominal rate. Okay, so in other words, the question is asking us, can you determine what R is? Now on our formula sheet, the easiest way to get at R is typically to find the periodic interest rate, which we call little I, and then use that, kind of multiply that by the frequency in order to get the nominal rate. So let's see if I can actually remember the formula for I. The formula for I is, this is the one where we take the weird power, I think, right? So we need to do something like this. So what we need to do is we need to find the ratio of the future value to the principal amount, raise this to a fractional power. This is either 1 over n or 1 over t times f, depending on what source you use to read here. And then once we find that number, we're going to subtract 1. So this is going to tell us the periodic interest rate, or the amount of interest I get during every compound period. And then once we find this decimal number, we can multiply it by the frequency to get back to the nominal rate. So here's where we're going to start. This is the formula. I'm trying to find an interest rate. So what I'm going to do is go to my formula sheet, grab the formula to calculate an interest rate. In this case, it happens to be I, and then we can use that to get what we want. So what do I need? I need the future value and I need the principal amount. Those are fairly straightforward, I think, to find inside the statement of the question. So our future amount here is 560.15, and then our present value is 300. The hard part, I think, is trying to figure out this fractional power. So what goes in the, I keep selecting green at the wrong time. What goes in the denominator of the fraction here? I think that's the hard part. That's what students tend to struggle with the most. So I'm going to go ahead and I'm going to underline some information. So typically what I do when I need to figure out what's going on with N or T or F is I need to figure out, one, how long the investment has been earning interest, and two, I need to understand the compounding structure as well. So yeah, I think we're getting some suggestions inside the chat here. So n equals 3, n equals 26 times 3. What are we thinking? So here's some information that we need. We need to know information about how long. Okay, so in our case, we know how long this investment has earned interest. It's been earning interest for 3 years. And we also have information about the frequency number. We know that it's going to earn interest every other week. So F is equal to 26. So yes, Kate and Emily, I do like your suggestions. We know there's a formula that N is equal to T times F. So any way we look at this, the number here in the denominator has to be 3 times 26. It has to be, what is that? What is 3 times 26? 78. So the number here has to be 78. It has to represent the total number of times that we've earned interest over the span of 3 years. And if we're earning interest 26 times per year, and we go through 3 years of that, we must have earned interest 78 times. Hopefully that makes sense for you. Okay, so either you kind of have to logically think through it. Okay, well, I've earned interest 78 times. That's what goes in the denominator. Or you just use the formula. What is N? N is T times F. We know that T is 3 years, F is 26. That's where we're getting our 78. Okay, so if you need to use that formula, it's there on the formula sheet for you, the updated formula sheet. And this is where we start. And what I'm going to do is I'm actually going to share my screen so you can kind of follow along with how I'm going to input this into the calculator, because this is a real, if you want to use the business math calculator, it's kind of a pain in the butt. We actually have to input it in the following way. We're going to be doing our 5, 60, 15. We're going to divide by 300. We have to use the Y to the X button to get the power in. But I need to be mindful that this is a fraction. So I need to do 1 divided by 78, actually in a set of brackets here. And then I'm going to subtract 1 and hit the equal sign. So in green is how I'm going to tackle inputting this into the business math calculator. So if you are using that calculator, you can kind of follow along here. Okay, so starting up with my first kind of big bracket, which is the division of 5, 60, 15, and 300. Okay, I'm going to close that bracket, and I need to raise this number to the power of 1 over 78. So I'm going to hit the Y to the X button, and in a bracket, I need to go 1 divided by 78. Okay, that's going to get that fraction in there. We're going to close that bracket. And then the last thing we need to do after that is subtract 1. And this should give us small case I. This should give us the periodic interest rate. Okay, don't clear that from your calculator, leave that in your calculator. I'm just going to write it down for us. Okay, so we know that I is equal to 0.008 37541. This is the periodic rate. However, we want the nominal rate. We want to find R. You remember how we talked about, I think it was it last class? I think it was the last class. We talked about this periodic interest rate and how we can find it by taking the nominal rate and dividing by the frequency number. So I know there's a relationship between I and R. If I take the nominal rate and divide by the frequency, I get the periodic rate. Or in other words, if I take I and multiply by F, that's going to give me the nominal rate or the yearly rate. Now they'll say, is your calculator set up to have 9 decimal places? That's my question to you. So if your calculator is not set up to have 9 decimal places, you might get 0.01 because your calculator might be rounding to 2 decimal places. So let me know. So you'll know if your calculator is only displaying 2 decimal places because it should have a 0.00 on it only on the main screen. Only 2? Yeah, okay. So I'll show you in a moment how to fix that. So just let me finish the question and I'll show you. If you're getting 0.01 here as an answer, we need to update your calculator, okay? I'll show you how to do that in a moment. So what I'm going to suggest here is I have the periodic rate. Let's multiply that by 26. This is going to give us R. Okay, so I'm just going to bring my calculator up. I'm going to take that decimal number. I'm going to multiply by 26. That will get us to the nominal rate. It's a pretty big nominal rate, 20.897%. And if we round this to 2 decimal places, we're going to be looking at this 7. The 7 is actually going to force my 9 to increase, which will force my 8 to increase as well. So rounded correctly to 2 decimal places, we should get 20.9%. So this would be an acceptable final answer. 20.9% would be half of what we need. And then you also need this statement to let the customer know when they're earning interest. So we also need to include the compounded biweekly portion of this nominal rate as well, okay? So we'll just go ahead and we'll circle that in red. This is going to be what we want as our final answer. So Dulce, if you want to just follow along with me quickly here, we can get your calculator programmed into 9 decimal places. You want to hit the second key, so the yellow button, and then the decimal. So this is going to get us into the format submenu. So second, and then the decimal. Yours probably says decimal equals to 2. What you want to do is hit the number 9. Okay, so hit the number, oh, not 99. Hit the number 9, and then hit the enter key. Okay, once you've done that, you can just leave, and then hopefully now you'll be able to do this to 9 decimal places. Okay, so try it one more time. Let me know if you can come up with the 0.008 answer now that your calculator will accept all of the 9 digits. Okay, how is everybody feeling about question number 1? So this is an example of when we need to use the little I formula in order to get the nominal rate. You'll notice often when we're answering these kinds of questions, at the very end, we will need to multiply by the frequency number to get the nominal rate. So that's a very common thing we do at the end. Okay, awesome. Let's move into, what do we got here? How much did you initially borrow? So it looks like we're going to be moving into an example where we utilize the principal amount formula. So let's take a look at number 2. So after 4 years of 5% compounded monthly interest, we pay the bank I wish I had $43,000. After 4 years of 5% compounded monthly interest, we're going to pay the bank $43,000. How much did we initially borrow? So it sounds like we've taken out a loan. We've allowed it to earn interest over 4 years at the rate posted, and then we owe the bank $43,000 after 4 years. So the question is asking us, what is the principal amount? How much did we initially borrow from the bank? Okay, so it's asking us essentially to find the principal amount. So I'm going to go to my formula sheet. I'm going to look for the principal amount for compound interest. Okay, so there's 2 formulas for capital P, either simple interest or compound interest. We want to pull out the one for compound interest, which says take the future value and let's divide by 1 plus R over F times, to the power of TF. So here's the principal value formula we developed. And did we develop this last class? This is the principal value formula. I can't remember if I showed you this last class. Okay, great. It really just comes from, dividing both sides of the equation by the bracket thing. Hopefully it's not mysterious. Hopefully it's not too mysterious for you. So that's the formula we need to use. So it's up to us now to go in and try to find the future value. We need to find R, we need to find T, and we need to find F. We need to find all of these things on the right-hand side of this equation. Okay, the easy one obviously is the future value. I know that that's $43,000. The next thing I want to do maybe is go take a look at the compounding rate. So this line here is going to give us some information about R. It's going to give us some information about F. So what is F in this case? R is 5%. What is F? How often do we earn interest? F is 12. We earn interest every month. Okay, so it looks like the last thing we're going to need is information about T. So now I have the 0.05 over 12, and then I need T times F. Okay, we have information about T right here. What's T? T is equal to 4. T is always in years. Yeah, awesome, they'll say, yeah. So we're going to input that in here into our power. We're going to input 4 times 12. Okay, 4 times 12 is 48. So in other words, we've actually earned interest, or well, the bank has earned interest from us 48 times over the span of 4 years. That's what this number represents. Okay, give that one a shot. Let me know what you get in your calculator for the principal amount. $35,220.05. Awesome. Yeah, let me verify that online as well. And there it is. Yeah, $35,220.05. Yeah, very nice. So if you are trying to input all of this at once, I recommend just adding an extra set of brackets in green right here. And that's going to help you input this correctly into the calculator. If you're still having trouble, then what you can do is you can evaluate the decimal number in the denominator first. And then you can take your $43,000 and divide by that decimal number. And then hopefully you'll come up with that answer of $35,220.05. Right, so do let me know in the chat if you're having a tough time getting that dollar amount. We can kind of talk about some strategies to make that work for you, but that I do agree is going to be our final answer for number 2. So in number 3, we are asking the question, how many years will it take an investment of 3,400 to grow to 5,000 if the interest is 3.5% semi-annually? How many years? Okay, how many years? So they're asking us to figure out how many years. So they're telling us, hey, can you tell me what T is? Right, I know the rate, I know the money amounts, both the principal and the future value. How many years? I think this is a very good question to ask. Right, a lot of people are like, hey, if I invest this now and I know it's going to come out to be this, how long is it going to take? Right, this is the amount of money I want. How long is it going to take me to reach that goal? I think this is a very common question to ask. Now notice that if you go to your formula sheet, there's not really a formula to solve for t, one of the larger formulas in the compound interest section. Right, there's no simple formula like for simple interest, right? I can't just do I divided by PR to get the t for compound interest. It's a little bit more complicated. Now, what we can do though is we can use a formula to calculate the total number of times we earn interest. That's the formula for n. So what I'm going to do here is I'm going to say, well, let's go in and let's use the formula to figure out how many compound periods we go through. And then we can maybe make an adjustment to figure out how many years. And so the formula for n is the natural logarithm of the future value over the principal amount divided by the natural logarithm of 1 plus I believe, or 1 plus r over f. So this is the formula we want. This is going to tell us how many compounds, how many total times we earn interest. And then kind of like what we did with the formula for I, we do a little adjustment at the end to figure out the number of years. Now this one's a little bit weird because we have to use the ln button. I don't know how many of you have worked with logarithms and know how to do calculations with logarithms. Our calculator doesn't make it super easy, but let's go and try to find some of the numbers we need to substitute in first. And then we can talk about how to kind of set up and execute a question that looks like this. So John, is it Jean or Jean? It looks like you have kind of the right numbers, just the decimal place is in the wrong spot. So if the decimal place is in the wrong spot, I'm wondering if you are starting with 4,300. I'm wondering if you accidentally are putting in 4,300 in the numerator rather than 43,000, because it just looks like you're out by a decimal number, right? Okay, perfect. Yeah, so like that's what. So if you get like if you look close, like if you look between the two, right? It's if you're kind of out by that factor of 10. So I think that's the issue here. This is fun. I'm used to troubleshooting in a classroom, not troubleshooting online, but. It feels good. I feel like I'm doing good when I can find a mistake like that and help you out. I feel good about that. Okay, so let's get back to part 3 of this first example. And what do we know? We know the interest rate is 3.5% semi-annually. So that's going to give us some information about R. We know R is 0.035. And we know F is what? How many times do we earn interest if we're compounding semi-annually? 2 times. Yeah, you're right, Andres. 2 times, twice per year. So that tells me what R and F is. Hopefully it's obvious what the future value and the principal amount are in this particular question. So let's take ln. Let's do 5,000 divide by 3,400. Let's do ln of 1 plus 0.035 over 12. Were you able to get everything to work out okay? Is it Jean, I believe? Yes, thank you, Kate. This should be over.
Yeah, I got it. Thank you.
Okay, awesome. And yes, thank you, Kate. So I've just adjusted that to 2. It should be 0.035 over 2 because we're semi-annual and not monthly. Saved me. Okay, this is where things get a little funky in the calculator. If you try to hit the ln button right away, so like let's say you're on like just the regular screen and you go to hit the ln button, it's going to give you an error 2 message. So what we need, I'm a little concerned about that, Dulce, because we need n to be a whole number. Usually, like we need we need it to be something, right, other than 0. That would imply that it's taken us, 0 compounds to get where we need to go. So there might be a small error in your calculation. Let's try to find it. What I do know about the calculator is you actually have to put the number in first and then hit the LN button in order to do the calculation. So if I'm looking, for example, at this first kind of like what's here in the numerator, I actually need to evaluate what's in the brackets first and then hit the LN button. So what you're going to see me do on my calculator is I'm going to go in and I'm going to say 5,000. Let's divide that by 3,400. And let's get a decimal number, okay, that represents that fraction. Once I get this decimal number, now I can hit the LN button to do the evaluation. So Andreas, yes, this is what I get for the numerator, about 0.3856. So I'm just going to go ahead, I'm going to jot that number down. I know it's a bit of a pain in the butt because we have to use all 9 decimal places for accuracy. Josh, I do think, I believe that's the answer for n. Yes, so I do believe that it should be around 22 for n here. But I'm going to go ahead, I'm going to just jot down that decimal number for us. And Andreas has it. And I just need to validate 1. So. And then once you're happy with the decimal number you get in the numerator, we're going to do the same thing for the denominator. We're going to try to get this bracket first and then hit the LN button afterwards. And so, yes, I do believe Josh has our correct final answer of 22.230129 or so. And now, Josh, my question to you is, we just need to make sure to finish off this question. This represents the number of compounds. So what we need to do to finish this off is to figure out how many years. So if we went through, let's say, 22 compounding periods or 23 compounding periods, how many years have we actually spent allowing our money to grow to $5,000? That would be my question. What would be my follow-up question for you? Okay, so I've done work for the numerator. We have to do work for the denominator as well. So you're going to see me put in 1 plus 0.035 divided by 2, and I'm going to get that as a decimal number, so 1.0175. That's the decimal number inside the brackets. Then I'm going to apply the logarithm to get the following number. All right, it's a bit of a pain in the butt here. You are going to have to divide these two numbers to get the 22.23. So this is, I'm just kind of guiding you through what I think is the easiest way to deal with this problem. So you don't have to like stress out about lots of brackets and stuff like that. Evaluate the numerator, evaluate the denominator, divide those two numbers. It's going to be a pain in the butt, but we should end up with 22.23. And Andreas, Nosh, yes, exactly. We should get 11.12 years altogether. Okay, so how did you get that final? How did you get 11.12? Where does that come from?
By dividing the compounds by the number of compounds in the whole term for by number 2, which is, you know, represents semi-annual.
Yeah, very nice. Okay, so we know there's a relationship between n and t. Our goal is to find t, right? So we know that we could take n, we could divide by f to get the number of years. So the last step in this question is to divide by the frequency number, which is 2. That's going to solve for t, and that gives us our 11.12 years. Okay, very nice, guys, very nice. So as you can see, you know, using the formula for n, using the formula for I, it's a little bit more complicated with compound interest, right? It's not quite as nice as simple interest. Some might even say, you know, if you wanted to venture a dad joke, you would say it's not as simple when it comes to compound interest. But that's just the dad in me. I'll stop joking around. Let me know if you're having any issues kind of doing this evaluation in the chat, and I can kind of hopefully help maybe find any errors. Well, thank you. I'm glad that I'm not the only one that appreciates a good dad joke every now and then. Yeah, this is the response I typically get from everybody when I'm in my face-to-face class is exactly what Josh posted. I get like little like moans and groans from my students usually. I think they're laughing internally. I think like I'd like to think that they're laughing internally at least, and not laughing at me, you know, laughing with me. When you're happy with getting 11.12, let's try another example utilizing the formula for n again. So that way you have at least a couple examples in your notes. Of course, there are more examples in the online version of the textbook as well. So if you do want some extra examples and you haven't had a chance to read this section yet, go to those sources that I posted for you on the Moodle page. So there'll be a few more examples for the n formula, a few more examples for the I formula in the online version of the textbook as well. So we're getting pretty close to the end of what my online version of the textbook contains. I don't unfortunately have anything on annuities inside the online version of the textbook. So I'm going to take some time this weekend to think about how I want to proceed with the course. We might end up going back to kind of the full 2-hour lessons, if that works for you, unless you're really happy with the structure of kind of reading and then coming to class to do work. But we could kind of extend, I don't know, let me think about it. I don't know, what do you guys feel? Do you feel like, you know, as we start to kind of move past test number 2 into what I would consider the more challenging part of this course, do you think it's going to be worthwhile for us to kind of talk about the theory together? Hey, that's a good idea. Let's do a poll. We got the time. So you guys, how about you guys start on working away at the next example here, and I'm going to start a poll for us. Okay, there it goes, guys. There is your poll. Okay, so there's 2 choices. If you want to keep the structure kind of as is, what I'll do is I'll try to get some pre-recorded lessons for you before the class. They'll be kind of like short videos posted directly to the Moodle page. I'll host them on YouTube probably. Just going through a quick kind of theory, like usually they're going to be like where the formula comes from or like any kind of important definitions we need. And then we'll still cover examples in that kind of 3 to 4 time period. And the other option is we could just cover the theory from 2 to 3, and then from 3 to 4, we could do the examples. All right, we're pretty split, I would say, in kind of how we want to move forward, but it does appear that about 2/3 of the class is happy keeping the structure as is. So we're going to roll with kind of what that 2/3 of the class would like me to do. And so what I'll end up doing is making short videos, posting them right to our Moodle page for the annuities section. I'll still be available between usually 2:30 and 3 o'clock. I'll still be available and around before class starts. So if you do have questions about the theory, you can always tune in between kind of 2:30 and 3. What about a compromise from 2:30 to 4? I mean, we could talk about compromise. I think, you know, most people, from my perspective, we're kind of we are in a habit, I think. You know, we've spent enough weeks working in this kind of format that I think most students are probably happy just to kind of stick with that format. So I'm tempted to not change things unless there's an overwhelming desire to change things. So what I would recommend is let's stick with the same format that kind of gives me at least a weekend in advance to kind of think about how I want to do this. We're going to focus mostly on the hard copy of the textbook for the annuities section, and I'll make very short kind of theoretical videos. And that way, if you do have some questions about the theoretical kind of video, you can always jump in at 2:30, let's say, Kate, to the Zoom chat. And we can talk about kind of the theory, you know, for the students that want to talk a little bit more about the theory and ask some questions. Let's do that. So that way, if you do have some questions or whatnot about the theory, you can always jump in and ask. Typically, the theory, aside from like maybe a definition or something like that, we don't really test you on the theory per se, right? Like I'm never going to test you on like where a formula comes from, but I do think it's important that you kind of see that and see the algebra. So yeah, I'll try to keep those short. I'll try them. I don't really want them to be hour-long videos, you know, but I do want to show you at least kind of the mathematics behind where stuff comes from. I think that is important. So I'll try to keep it kind of brief with the theory videos, you know, like this is the difference between simple interest and compound interest, blah, right? And kind of keep the examples focused in that 3 to 4 section. Cool. So I'll kind of roll with that, guys. That gives me a little time to kind of think about how I want that to look like. So that's perfect. Thank you for that feedback. I always appreciate that. Okay, so in our next example, we are curious about how many weeks it's going to take an investment to grow from 2,000 to 3,000 if interest is 7% compounded monthly. This is a toughie because it's asking how many weeks. It's not asking how many years, but we still need to find t. If I could figure out how many years it takes for this investment to grow from 2,000 to 3,000, I could kind of figure out how many weeks by multiplying by 52. Hopefully that makes sense. So the end goal here is, hey, let's find the number of years it takes, and then let's scale that around to figure out how many weeks it's going to take. So in other words, we need to set up the formula for n again. And I'm going to scan through. Hopefully it's obvious what the future value and the present value is. The other information I need is information about the compounding structure here. So I'm given that R should be 7% and that F should be 12 because this is a monthly kind of compounding. So let's go ahead, let's input these values in. We should be doing ln of 3,000 over 2,000 divided by ln of 1 plus R over F. And so again, what we want to do is just input the brackets into our calculator first. I'm going to do that kind of by hand. If you would like to see that, let me know. I can do that for you. What's most important is understanding, or sorry, verifying that we get the same decimal numbers here. So it looks like Andreas has the numerator correct. And I'm just going to go ahead, I'm going to verify your denominator as well, okay? Okay, so 1 point, that's not right. 1 plus 0.07 12. That. And looks like your denominator is correct as well, Andreas. So 5, 8, 6, 3, 8, 5. Perfect. So if we are happy with those two decimal numbers, we should be able to divide those, and then we can figure out how many compounds we've actually went through. 405, 4, 6, 5, 108, 6, 8, 5. Okay, so we end up with, I believe, yeah, 69.71. Perfect. So I'm going to just kind of keep that full decimal number because I do want to do a little bit of work with this decimal number, and I want my final answer to be as accurate as possible. So I'm going to take all of those decimal places, and then you're going to see me do a little bit of work to figure out the time in years. So we know that the time in years should be n divided by f. We know our frequency number is 12. So if I take this 69.71 and I divide by 12, that should tell me how many years it took for this investment to grow. So let's say it takes about 5.809 years. What we would like to do is figure out how many weeks it took for this investment to grow. If I know it's taken about 5.8 years, if I multiply this number by 52, which represents the number of weeks in a year, then I should hopefully get, yeah, that 302.08 weeks. So that's kind of the last idea here. We need to multiply by 52. And I get the same number here. So I get about 308.52 weeks. Very nice. Perfect. So there's just another example of kind of utilizing that n formula. Anytime we need to figure out a length of time for compound interest, we use that formula to calculate n, right? As soon as I get the number of compounds, then I can kind of start scaling that number in a way that makes sense for the question at hand, right? So most often we're going to be asking the length of time in years, but I don't have to. I could ask how many months, or I could ask how many weeks. I could ask how many days, right? We could ask to scale that for our customer as well. So, but the big thing is find n first, and then if you need to kind of scale things around, find t, and then use the number of years to kind of get what you need. That's the general kind of way to tackle these kinds of questions. Find n, find t, and then scale it around if you need to find something else. Okay, I want to work on one more example with you today. One more example of calculating an interest rate. So in this second part of this example, again, we're going to be determining the nominal rate. We're going to be finding r. If we know some information about our investment or loan. So in this case, what do we got? We got a loan that grows from $400 to $670 over the span of 5 years. Okay, so we didn't make any payments on this loan.
Sorry to interrupt there, Brian. Just on the last one there, how did you get 308.52 weeks? I got 302.08 weeks.
Oh, did I just, I might have just, I could honestly have just written something down incorrectly. Sorry, guys.
All good.
Okay, so what did we say? We needed to actually, sorry, multiply that by 52, 302. Yeah, I was way off. Geez, what am I looking at? So yeah, 302.08. And that's so funny because I like literally looked at 302.08 that everybody got, and I was like, yeah, that's exactly what I got on my calculator too, but I wrote it down wrong. What the heck? Okay, hopefully that matches up with what everybody else has given in the chat. And thanks. I'm always happy when you guys call my bluff. I'm just checking to make sure you're still paying attention. No, I'm just kidding. I totally shit the bed, but thanks for catching that for me, guys. Okay, so let's work on this last question. I got 3 minutes to kind of set this up and execute it for you guys. So we are going to be using the formula for I. We need the future value divided by the principal amount to be 1 over n minus 1. So the hard part here again is trying to figure out what n is. We know that n is t times f. So I need information about the time in years, and I need to know the compounding structure of this particular loan. I have information about the time in years here, and I have information about the frequency of compounds here. So n is going to be equal to 5 years of 52 times per year. That's a lot. So we've essentially earned interest, or the bank has accrued interest 260 times over the course of 5 years. That's really the hard part in my opinion. So now I can just start substituting all of our values in. So our 670, our 400, and our 1 over 260. And hopefully we can kind of quickly get at that periodic interest rate. So again, I'm going to go ahead, I'm going to do this not by sharing the screen. I'm just going to do this on my calculator at home, just for sake of keeping everything nice and quick. So here's what I get. And hopefully someone can verify that they get the same periodic interest rate. So I get like 0.00198. Okay, great. So this is the periodic rate, and we know that if we want the nominal rate, that's equal to the periodic rate times the frequency number. Our frequency number is 52. So we're going to multiply by 52. And hopefully that will give us the nominal rate. Hopefully we all get around 10%. So rounded to 2 decimal places, I'm going to get 10.33. And this is compounded weekly. Okay, so this is our final answer. Why am I getting scientific notation? Josh, it might be because of how you're inputting the power. So I'm just going to share my screen and I'll go through again kind of the way that. Yeah, so my guess is it's because of this exponent of 1 over 260. That's usually where the error happens here. So if we do our 670 divided by 400, and we get that decimal number, I need to raise it to the power of 1 divided by 260. But I need to put those in brackets. So I go y to the x, bracket 1 divided by 260. And then close that bracket. Okay, and then the last step is always to subtract 1. So you just have to be really careful about inputting that power. And that's typically when students are going to get kind of, if you notice like a funky answer, like exponential notation, it's probably because you put that exponent in kind of in a funky way. The only other thing that you could check, Josh, is whether or not you're in CHN or AOS mode. Have you been able to get all of the other calculations to come out okay, or is it just specifically this one? Yeah, all the other ones came out okay. So I'm not really sure. I'm not really sure what to potentially say here. It probably has something to do with that Yeah, try the other calculator for sure. It probably has something to do with how you're inputting the 260. Because I mean, if you have a number and you're taking it to the power of 260, you're going to get a really big number. You're going to get exponential notation. So I just have a feeling it has something to do with how you're inputting that fractional power. Okay, that's all I'd like to cover for today's class, guys. So if you have any questions, kind of stick around. I can hopefully answer those questions for you. But otherwise, have a lovely, lovely weekend, and kind of finish up the last kind of spattering of things we need to on Tuesday. So we got to go over the rule of 72, and then I want to kind of cover how to utilize the time value of money buttons actually on the calculator to do some work as well. Yeah, hopefully you guys have a great weekend as well. Thanks for all the wishes. I always appreciate it, guys. No worries. Yeah, thanks all of you. Thanks all of you. Enjoy your sunny day in Lytton, Paige.
Thanks, Rob. Have a great weekend.
Yeah, you're welcome. Thank you.
Thanks a lot, Professor. Have a good weekend. See you.
Yeah, thank you. No worries.
Have a good weekend.
Thank you. You too. Blake, yes, this is going to get posted to Moodle a little bit later. Not immediately, but maybe by tonight. Okay, just got to let it render in YouTube first. Yeah, cheers, man. Have a good one.